Okay, this video we're going to talk about Cepheid variables. We'll also talk about the kind of exam questions you might be asked about Cepheid variables. So what is a Cepheid variable? Well, a Cepheid variable is a type of standard candle. Now, a standard candle is an object and we know how bright it is. So this means that if it looks very dim, it's far away. If it looks very bright, then it's very close. How do we know this? Because we know how bright it is. How bright an object appears depends on how far away it is, and it depends how bright it is. So basically, if we know how bright this particular object is, and we measure how bright it appears to be, then we can work out how far away it is, which obviously makes it very, very useful in astronomy, because if we see one of these objects and we measure how bright it is, we can work out how far away it is. It's called a standard candle. What exactly is a Cepheid variable? Well, there we go. A standard candle is an object of known absolute magnitude. If we look at this star, and this star is pulsating, it's getting brighter and then it's getting dimmer, etc. Why is it doing that? There are several theories as to why it does it. Is it perhaps because the gravitational forces pulling it inwards and the radiation pressure pushing outwards are varying, a bit like a mass bouncing up and down on a spring? I read something to do with ionized helium in the outer layers becoming less dense and letting more light through or whatever. But for the GCSE, we don't need to know why. Basically, it's a star that gets brighter and dimmer over a period of about, let's say, a week is typical. And what we can do is we can measure the period. Here we see the apparent magnitude gets bigger and smaller and bigger and smaller, and this is a typical light curve for a Cepheid variable, and if we measure it over a period of a few weeks, we can measure its period. Now that was one Cepheid variable. This is another Cepheid variable. Now what differences can we see? Well, first of all, it's brighter. Possibly because it's larger, it's brighter. Also, its period of this pulsation is bigger, and perhaps there's a relationship between the period and the brightness of the Cepheid variable, and there is, and that is the relationship. And basically what we're saying is that the brighter the star is, the greater its absolute magnitude, how bright it actually is, then the greater the period. So the bigger, brighter Cepheid variable takes longer, it has a larger period of pulsation, it takes longer to get brighter and dimmer and brighter and dimmer. The smaller Cepheid variables pulsate quicker. Well, this is very useful because that means that if we can measure the period of a pulsating Cepheid variable, then we know its absolute magnitude. Okay, why are they called Cepheid variables? Because the first one, which was discovered, which is apparently in the 18th century, was Delta Cepheus, the fourth brightest star in the constellation of Cepheus. That's why they're called Cepheid variables. So let's say we are looking at a faraway galaxy. Let's say this is Andromeda, and looking inside Andromeda we see a star which is getting brighter and dimmer, and the light curve we recognize to be a Cepheid variable. So what do? We measure the period of the pulsation. From that graph we saw earlier, we therefore know the absolute magnitude. We know the apparent magnitude, and if we know big M and little m, then we can work out the distance in parsecs using an equation which I talked about on another video. So measure how long it takes to get brighter and dimmer, use the graph to find its absolute magnitude, big M, measure how bright it appears, and then calculate how far away it is. Okay, Cepheid variables aren't the only standard candles, there are other ones. Type 1a supernovae are standard candles. This is where we have two stars, a binary system, typically a small, very dense star and possibly a red giant, and the small dense star is gobbling up the red giant. When it reaches a certain mass, it explodes in a very, very bright flash, a supernova, and then interestingly the process starts again, and that very bright flash is of known brightness. We know how bright it is, therefore it is a standard candle. Another standard candle are the very biggest, brightest stars, blue supergiants, tend to be the same brightness. So if we see a big blue supergiant, we know how bright it is. It is therefore a standard candle. Thank you very much. Visit my website, astronomygcse.co.uk. Perhaps subscribe to this video and more will appear in the post. Thank you.